Section 2, Video 7. Now again, we have a situation here where we have roots around the fraction, one in the denominator, and that's a problem. But if we look closer, we notice that root 4 can be simplified. So we have 4 plus 3 root 3 over 4 times, and the root of 4 is 2. So you end up with 4 plus 3 root 3 over 8. Now one would say, let's simplify the 4 and the 8. But because of the plus sign, these are locked together, and you cannot affect one without the other. So we have to remember that they have an invisible shield, per se, protecting both of them, locking them together, so we cannot simplify one part without both. So this must be considered finished. Let's take a look at another example here. Now this is an example where we have a root that is not simplifiable. It's root 6. Now, it's very important to understand that we cannot have a root in the denominator. And it is at this point that I'm going to show you a nice little trick to help us simplify things with roots. Now, if you happen to have a root on the top and the bottom, then the root of 15 over the root of 6 is the same as the root of 15 over 6. You can write them together. Now it's important because notice that 15 and 6 can be simplified. And that would be 3 goes into both, so we have 5 halves. Now again, that can be rewritten in their own little roots. And that's important because now this fraction that we started with becomes 4 root 5 over 5 root 2. I forgot my little root symbol here. Okay, so what does that mean? Well, what we've done is we've made the numbers smaller to deal with. Now again, we don't have to do this step first, but it really does help in the long run when it comes to simplifying these kinds of questions. So all we did was we wrote the roots underneath one root, because we noticed that the numbers can be simplified. They had something in common. In this case it was a 3. We brought them in the same root to simplify the fraction. Then we put them back into their own roots and went back to the question. Now that's an important step, because now when we say, how do we fix this? We have a root in the denominator. What can we do? Well, the step is called rationalizing. We rationalize the denominator. And what that is we multiply top and bottom by the problem. And the problem is root 2. So if we multiply by root 2, but again we have to do it to top and bottom, otherwise the fraction is not proportional, we will end up with 4 root 10, because remember root times root. And on the bottom we have 5, then we have root times root, which gives us root 4, which we can actually calculate. So 4 root 10 over 5, and the root of 4 is 2. So this will equal 4 root 10 over 10. Now, I have a root 10 and a 10. They are not the same thing. One is actually a decimal, because the root of 10 is 3 point something. So you cannot simplify those numbers. You can only affect numbers that are on the outside of roots, or on the inside of roots, but not a combination of. So here we have a 4 and a 10. Well, we know that 2 goes into 4 twice, 2 goes into 10 5 times, so our final answer would be 2 root 10 over 5. So many little steps there. The key piece that we want to bring to light here is that this process right there is called rationalizing the denominator. And that's the new phrase in terms of simplifying fractions with roots in the denominator. And this ends Section 2, Video 7.